In orbit, 400 kilometers above Earth, there is a system that decides your fate. It doesn't ask your opinion. It doesn't wait for permission. It calculates, measures, and determines who stays and who must leave. Every person aboard a space station consumes resources: oxygen, water, power, food. But here's what most people don't know. There's a hidden algorithm monitoring everyone. It's called the Life Support Priority Matrix. And it's always running. If something goes wrong, if a solar panel fails, if a water recycler breaks, this system immediately recalculates who is essential and who is expendable. The silent grid isn't a person. It's not a committee. It's a network of sensors, thresholds, and automated protocols. Every breath you take is measured. Every liter of water you use is tracked. The station knows your metabolic rate, your skill value, your mission criticality. If resources drop below a survival threshold, the grid activates. It begins sorting crew members into 3 categories: critical, secondary, returnable. Critical personnel cannot be removed. They keep the station alive. Secondary personnel support operations, they're protected until the numbers change. Returnable means exactly what it sounds like. You will be sent back to Earth, not as punishment, not as failure, simply as necessity. The station cannot support everyone, so it chooses who leaves first. The decision is made in milliseconds. Food stores. And once the grid decides, there is no appeal, no debate, only preparation for departure. This isn't science fiction. In 1997, the Mir space station experienced a collision. A cargo ship struck a module. Pressure began dropping. Oxygen levels fell. Within hours, Mission Control considered evacuation protocols. Who would stay to repair? Who would return? The decision was made using resource calculations. Skill priority, survival mathematics. On the International Space Station today, every crew rotation is determined by similar factors: mission duration, resource consumption rates, return vehicle capacity. If an emergency occurs, the station's Environmental Control and Life Support System, CLSS, provides the data, and that data determines who boards the escape capsule first. Let's examine the most critical resource: oxygen. A single human consumes approximately 0.84 kilograms of oxygen per day. The ISS can support 6 to 7 crew members comfortably with current systems. But if the oxygen generation system fails, reserves last only 48 to 72 hours. At that point, the grid calculates a new maximum capacity. Perhaps only 4 people can survive until rescue, perhaps 3. The system doesn't delay. It immediately identifies who must evacuate. Water follows the same logic. Every space station operates as a closed-loop system. Urine is recycled into drinking water. Humidity is captured from the air. But the system is never 100% efficient. There's always loss. Every week, a small percentage of water disappears, absorbed, chemically bound. Resupply missions bring more, but if a resupply is delayed or fails, the grid recalculates. Water reserves divided by crew size, days until crisis, and once again, it decides who can stay and who cannot. Power is another silent variable. Solar panels generate electricity. Batteries store it. But if panels degrade, if batteries fail, the station enters energy rationing mode. Life support systems consume the most power. Then thermal control, then communication. If power drops below a critical threshold, non-essential systems shut down. Heating in certain modules stops. Lighting dims, science experiments halt. And then the grid asks, how many people can this reduced system support? The answer determines crew reduction. Immediate return schedules are calculated. Mission Control receives the recommendation, and the countdown begins. Now imagine being aboard that station, knowing the system is always watching. You don't see the grid, but you feel it. In every task assignment, every resource audit, astronauts are trained to understand this reality. They know the rules before launch, but understanding doesn't eliminate the weight of it. Some crew members report a constant low-level anxiety, a sense of being evaluated. Others describe it differently, as clarity, as purpose. You are here because you are needed, and if you're no longer needed, you return home. That's the agreement. That's the system. This system will scale as we build lunar bases, as we establish Martian colonies. The silent grid will become more complex, more autonomous, more unforgiving. On Mars, there is no quick return. A launch window opens only every 26 months. If the colony's life support falters, evacuation isn't immediate. It's delayed, possibly impossible. So the grid must decide even earlier who stays productive, who becomes a liability. It sounds harsh, but in an environment where air is manufactured and water is currency, survival depends on mathematics, not morality. This raises difficult questions. Who programs the grid? Who sets the thresholds? Should a scientist studying climate patterns be ranked equal to an engineer repairing oxygen systems? Should age matter? Health, years of training. These are not abstract debates. These are decisions being made now. Space agencies develop these protocols in classified sessions. Mission planners run simulations. They test different scenarios, different crew compositions, different failure modes, and each time the grid reveals the same truth. Not everyone can be saved. So here is the question we must confront as we expand into space. If a system can calculate your value in liters of oxygen and kilowatts of power, what does that say about the future of human life beyond Earth?